has to be equal to -1. So +1 plus another 4 plus a -6 equals -1. So the carbon equals +4. Does that make sense? They have to add up to whatever the charge is. If there's no charge, if it's a molecule and not an ion, it'll add up to 0. What's wrong, Annalena? Your head hurt? All right. Let's look at the slide after the periodic table. We've got a few more examples. A couple of examples, we'll have this down. NaIO3. What will the oxidation numbers of all these elements add up to?
0.
They will be equal to 0. There's no charge here. It's a molecule. Actually, it's a formula unit. An FU, if you will. Because it's ionic. All right, what's the sodium? Do we have a rule for sodium? I'm just going to write 1. Positive 1. Is there a rule for iodine? No, so let's come back to it. What about oxygen? Huh? -2. Let's make a distinction here. The oxidation state of oxygen in this Fu is 2-, not 6-. It's 2-. Okay? There just happens to be 3 of them that are 2- each. So we're going to have 3 times -2. Okay? So it's all going to add up to 0. What must be the iodine? 5. Easy peasy. You want to do one more?
Sure.
Yes?
You don't want that line,
One that's not in the notes. How's that? Dichromate. Huh? This one's a little harder. What's it going to total up to? -2. Do I know chromium? No. Do I know oxygen? What's it going to be? The oxygen here is -2. So I've got -2 times 7. So that's -14. Yep, she's got it. It's going to be 2 times +6 plus -14 equals -2. So the oxidation state of the chromium is 6. Not 12, 6. There's 2 chromiums. Don't be distracted by the pretty pictures. No. That's my progeny. Any questions about this? Okay, then we need to figure out why this is relevant. Relevant? No, it's not irrelevant. It is relevant.
Nobody likes relevant.
That would be a good time to pause and start again.
I don't know exactly. I know, right?
Okay. We are going to learn to balance equations balance redox equations by what's called the half reaction
That
method.
one you told me last week, they used to the blue and the blue this one.
Sure, why not? Yeah.
It was in the.
Balancing by the half reaction method is slightly different than I learned in college, but it's a little better, it's a little more comprehensive, and it's the way you'd expect to do it on an AP exam. So that's how we're going to learn it. Okay? The first thing we have to do, we look at our equation, and this solution is acidic. Okay, and you've got the steps for balancing a redox equation using the half reaction method in acidic solution, and then down below in alkaline solution. That means basic, Annalena. Okay, we're going to start with an acidic solution. Okay, the first thing you have to do is go along and figure out the oxidation number of every element. What's the oxidation number of my Mn2+? 2+. Okay, what's the oxidation number of my oxygen? 2-. Okay, so what's my bismuth? 5 what? 5+. Okay. All right. What's my oxidation number of the oxygen here? 2-. So what's the manganese here? 7+. Do y'all see where he's getting this?
No.
It has to add up to 1-. Oxygen is 2-, there's 4 of them, that's 8-. So it's going to take a 7+ to get to 1-. You probably missed this one too then, didn't you?
Yeah.
Yes, they have to total, just like we were just doing. The oxidation numbers have to total up to 1-. Oxygen is 2-, there's 3 of them, so that's a total of 6-. To get to 1-, the bismuth has to be 5+. Okay? And then here, what is the bismuth? 3+. Okay. What species up there is being oxidized? Huh? What species is being oxidized? Oxidize means losing electrons. The Bi is, let's think this through. The Bi is going from 5+ to 3+. It's becoming more.
It's gaining electrons.
It's becoming less positive.
Gaining electrons.
It's gone from 5+ to 3+. It's less positive. So that means it's getting more negative. So if it's getting more negative, that's gaining electrons. You want to try again? Denaria. What's being oxidized?
The Mn.
Why the Mn?
Because there's more. It's more positive. It's getting more positive than
It's
negative.
getting more positive. So if it's getting more positive, that means it has lost electrons, because electrons are negative. So our half reaction for the oxidation, our oxidation half reaction. Hello, Tamara. Our oxidation half reaction is Mn2+ going to MnO4-. That's the oxidation. Okay? That's the half reaction. We're splitting it into oxidation and reduction half reactions. Okay, what's being reduced? Grr.
The B.
This.
What's being what?
BiO3- is going to Bi3+. Okay? Why is that a reduction? It's gaining electrons. It's going from 5+ to 3+. It's less positive. It's gaining electrons. Grr. Okay? Now, We got our half reactions. Let's follow our steps. Step 1, separated half reactions. Yay, we did step 1. Huh? Step 2, in each half reaction, balance all elements except for oxygen and hydrogen. Done. They're all ones, aren't they? Step 3, balance oxygen by adding water. Okay, I've got 4 oxygens on this side, so I need to add 4 waters over here. We are in aqueous acidic solution, no problem, we got water. Okay? We've got 3 oxygens on this side, so I'm going to add 3 waters. No.
Wait, that's only
3. Do as I say, not as I do. Balance hydrogen by adding hydrogen ions, which is cool too because we're in acidic solution in amine. So I've got, because I added these waters, I've got 8 hydrogens over here. I'm going to add 8 hydrogen ions on this side. And here I added 6 hydrogens. So 6 hydrogen ions on the left side of my reduction. Are you with me? Where did I lose you, Daneria? Yes, I'm dancing.
Why did you add, I know that's just like one, the one in Wednesday.
Why did I add what? Okay, I had this MnO4. I got 4 oxygens here. I'm adding water to balance it. Each water has 1 oxygen, so I added 4 to balance out the oxygens. Can you see how adding that water balances the oxygen? But now I've introduced hydrogen, and I've introduced 8 hydrogens, so I'm putting 8 hydrogen ions on this side to balance it. It's okay. We're in aqueous acidic solution. We have plenty of both. Okay? We're just making it balance. So we've balanced for all the elements, haven't we? All right. Balance charges by adding electrons. Okay. Let's think about this very carefully. In our oxidation, where we're losing electrons, Leo, the manganese is going from 2+ to 7+. What's the difference in electrons between 2+ and 7+? 5. So we've got 5 electrons. Now, which side has more? This side or this side?
the right side.
The right side has more electrons?
No, the left side has more electrons.
Which is it?
The one with the less positive.
The right side has more on the left.
No, the left side has more electrons. Right side.
Left.
So it's left.
This side, the manganese is 2+. This side, it's 7+. It's more positive over here. That means this side has less electrons.
So I was right.
Okay? So to balance for electrons, I'm going to add 5 electrons to the product side of my oxidation. Plus 5e minus. That's an electron right there.
But it would be just to one side when we go.
Now this one's balanced. We haven't got to the reduction yet. Okay? Electrons are matter. They don't just come out of nowhere. We have to account for them. And now we're doing that. An oxidation reduction has to be balanced for electrons because you're transferring electrons.